This is section 8.5, solving exponential equations. So there are two methods to solve exponential equations. The first one is to get the same base, and we're going to go through that. You should always try this one first. Always try first. Okay, if that's not going to work, then you can go to the second method. I'm going to go ahead and write down the name of it on top of page 83. The second method is to use logarithms. Okay, so first we're going to see if we can get the same base, and if that doesn't work, we're going to have to use logarithms. All right, so let's go back to the first method. We've kind of talked about this already when we were solving the log equations. So what I'm going to do is look at the two sides of my equations and see if I can get the same base on both sides. Get same base on both sides. Sometimes you can. This is a very common ACT and SAT kind of topic, this getting the same base on both sides. And again, we did something similar to this. So can I get this 1/8 and this 4 to be the same base? Well, I know that I could write 4 as 2 squared. So think of the 1/8. Isn't 1/8 like 1 over 2 to the third? And that's being raised to the x plus 1. I don't really want fractions. So if I bring that 2 to the third up, I could think of it as 2 to the negative 3. And then that's being raised to the x plus 1. So do you see now I've got the same base, because if you think about it, when you raise a power to a power, you multiply your exponents. So I've got 2 to the negative 3x minus 3, because when you multiply, you got to distribute, right? And that equals 2 squared. So I got the same base on both sides. And then the last step is set exponents equal to each other. Equal to each other. So I'm going to set negative 3x minus 3 equal to 2. Negative 3x minus 3 equals 2. And then can you solve? Sure. Add 3. Negative 3x equals 5. And x equals 5 over negative 3. And again, on these, it's okay to have a negative answer because there's no logarithms in the problem. Okay? Look at number 2. Start by, can you get the same base on both sides? Well, let's see. I know 27 could be 3 to the third, and that 27 is being raised to the x minus 4. So the 1/9, well, I know 9 is 3 squared, but since it's in the denominator, if I bring it up, couldn't I think of that as 3 to the negative 2? So in place of 1/9, we have 3 to the negative 2, and that is being raised to the 2x plus 1. So in this case, when we raise a power to a power, we're going to multiply exponents, but we're going to do it on both sides. So this one is going to be 3 to the 3x minus 12, and this one is going to be 3 to the negative 4x minus 2, right? Because I multiplied these two exponents, and then I multiplied these two exponents. And so now that I have the same base, notice they both have a base of 3, I can set my exponents equal to each other. So this exponent of 3x minus 12 has to equal this exponent of negative 4x minus 2. And now it becomes a pre-algebra problem, right? Get your x's to the same side. So let's see, I'll move my x's to the left. So 7x equals, I'll add 12. So I think that's going to equal 10. And x equals 10 over 7. Okay? So one more. Ooh, notice I've got fractions on both sides. Well, the 3 and the 4, there's nothing I can really do with that. So I'm going to leave the left-hand side, 3 over 4 to the x plus 2. Okay, I may not know exactly where it's going yet. I do know that 16 is 4 squared and 9 is 3 squared. And that's being raised to the 3 minus x. And notice, since they're both being squared, I could think of that parenthesis. So let me make sure we're looking. I could think of this part as just a 4 over 3, the whole thing squared, right? Because that means they're both being squared. But then again, isn't that green box being raised to the 3 minus x? So do I have the same base? Oh, so close, right? On the left, it's 3 over 4. On the right, it's 4 over 3. Whoops, I was trying to get rid of that. Well, darn it. There we go, sorry. Why don't I clean up the left side? On the left side, I have 4 over 3. If I raise power to a power and multiply my exponents, I'm going to have 6 minus 2x. And why don't I do this? Notice 3 over 4 is the opposite direction of 4 over 3. Well, remember we talked about a negative exponent will flip it over. So instead of 3 over 4, what if I write it as 4 over 3 to the negative 1? Wouldn't that be the same as 3 over 4? And then that 3 over 4 is being raised to the x plus 2. So actually on the left, I have 4 over 3, multiply your exponents, to the negative x minus 2. On the right, we have 4 over 3 to the 6 minus 2x. Okay, so even though both sides are fractional bases, I still have the same base, right? 4/3. That means this exponent of negative x minus 2 has to equal this exponent of 6 minus 2x. And that quickly have a basic equation. So I'll get my x's on the left. If I add 2x, I'm going to have x. If I add the 2 to the right, I'm going to have 8. Okay, so that's the getting the same base method. And in the next video, we will put up the method on using logarithms.